We continue here with substitution, but this time we're going to do a nonlinear system. So that means that these two equations you see here, they're not both in the form y equals mx plus b, or they can't be changed to that form. Now the second one is a linear equation, the first one is not. So we want to use substitution for this, and it's really going to be quite similar to the last one as far as the overall process. Solve for one variable, for a variable in one of these equations, plug it into the other, solve it, take those results, plug it into one of the originals. So in this case we look at the two equations we have here, and it appears that this one is pretty much ready-made for it. It's already solved for y, so let's use that one as our first step. We're going to take this and plug it into the other equation. So here's the y in the other equation. We're going to plug all that stuff in there. So that'll give us 2x plus 2x squared plus x equals 20. Now this, right off the bat here, is looking like a quadratic equation. So we're going to treat it as that and move everything to one side, put it in standard form. So I'm going to combine the 2x and the x. I'm going to subtract the 20 over to the other side, put it in standard form, which is going to give me 2x squared plus 3x minus 20 equals 0. And so now we've got a quadratic equation that we are probably a little bit more familiar with. At this point, the best way to solve this one is by factoring. This one can be factored. And we start off with, and this might be a place to pause the video and see if you can remember how to factor this one. But I'll tell you how here in just a second. One thing you'll know is that we have 2x squared, so that means we put a 2x and an x in the starting positions. Then we need to multiply to negative 20, we need to add to 3x. The way to do that in this case is by minus 5 and plus 4. Notice that negative 5 times 4 is negative 20. In order to get this 3x, we look at the O and the I of FOIL. So we have here negative 5x for this one, and this one is 8x. And this, as you can see, those add together to give you 3x, and that's what we're looking for. So this is the correct factorization. Now if we have that factorization, we use these as mini equations, solve for x. That's going to give us two solutions. X equals 5/2 for the first one and negative 4 for the second one. Now we're going to take those and actually solve this system. Now the solution to a system is basically wherever these two cross. They're going to cross at two different points here. So we need to work with one for each of the ones that you see here. Let's take these solutions for x, plug them into the simpler of the two equations, which again I think is this second one. That's going to work a little better because it's linear. So we'll plug that in. Let's start with the 5/2. We plug that in as 2 times 5/2 plus y equals 20. So then we have 5 plus y equals 20, which means that y is going to equal 15. So if y is equal to 15 and we were using 5/2, that means that one of our solutions, one of our points, is going to be 5/2 15. So we take that as one of our two solutions. Our other solution, now let's look at the negative 4, plug that into this equation. So we have then negative, let's see, where'd it go? Okay, 2 times negative 4 plus y equals 20, so that gives us negative 8 plus y equals 20, which means that y is equal to 28. And since that was y equals 28, we had x equals 4 up here. That means our other solution point is going to be negative 4, 28. Never a bad idea to punch this in on your calculator and just see if those check out. Check it by looking at your calculator. It's going to be a little difficult sometimes to get the right viewing window, but you can also take these points, plug them in, and see if they work in both of those equations. So that is solving non-linear systems by using substitution.